This is for Year 11 Methods. It is the Chapter 3 SAC for 2014 and it's question 4D, E, F and G. Mr. Tollefson has nominated a number of special points that would suit bike path locations. Using these points, develop equations of polynomials that would pass through all these nominated points, express functions in exact form. Okay. So since these are in table form, I'm going to use stats, and I'm going to use stats unless I don't get exact answers. And then I'm going to have to use main and simultaneous equations. So we're going to stats, edit, clear all, okay. And my first set of numbers are 0. I'm going to pause it while I enter my numbers. Okay, I've quickly entered my numbers. The x's went in list 1. Y's went in list 2. Now, I'm not quite sure exactly what type. I'm looking at some sort of 50, 8, 0, 2, 8, 50, and there's symmetry involved here. I'm probably thinking quadratic because cubics aren't symmetrical, but I'd have to think about that just slightly. So I'm going to go calc, quadratic regression, x is in list 1, y's are in list 2, go OK, and bingo. I got r squared equals 1. So x equals 0.08, that's the value of a, so that's the value of a. B equals -4, c equals 50. So I've got negative 0.08 x to the power of 2 minus 4x plus 50, and if I go OK, perfect parabola, I can see that I'm going to main and I type 0.08 and I'm in standard and I press XE, that's 2 on 25, so I can go 2 on 25 up here if I preferred. So 2x power of 2 divided by 25 might be a preferred way of writing it. Okay, so that's the first one done. Looking at the second one, I'm going to go back over into graphs and tables and I'm going to enter those and I'll just pause while I enter. Okay, so I've entered this data for part E. Looking at the numbers, they're increasing. I've got a lot of points, I might do a quadratic regression again. Okay, a is 0, so 0 times x squared. So it's not a quadratic, it's actually a linear, where it's 0.7 times x plus 0. So it's equal to 0.7x or 7x divided by 10. Okay, that's that. Looking at the next one, okay, enter, resize, I've got 50, I'm not confident I'm going to get exact answers for this one, 160 divided by 9, 0, 10 divided by 9, 0, and 10 divided by 3. And if I do calculate maybe a cubic regression, okay, I get some non-exact answers here. R squared is 1, so it is a cubic. I've got negative 1.11111. I've got 0.1222222, negative 4.33333. Okay, so I know it's a cubic. Okay, so this is giving me decimal rounded answers. However, I do note that I have repeating decimals. I've got negative 1.111111111 to the power of negative 3. So that is negative 0.001111 because the decimal point's been moved 3 places to the left. So that's not an answer in exact form. I'm going to have to go into main and turn those into exact answers. And looking at the last one, I could enter it in, but I can see y equals 25, 25, 25, 25, 25, 25. I've got a horizontal line at y equals 25, so that's going to equal 25. So I'd like to jump back over here, and I'd like to go into main. And I can turn these into exact because they're repeating decimals. If I put negative 0.0011, that just puts that as 11 over 10,000, which is incorrect. But if I put a lot of the recurring decimals in, like fill the whole screen, it will then turn that into exactly what it is, which is negative 1 on 900. So I've actually got negative x cubed divided by 900, which is the exact value. So if I look at the same with the next one, if I go 0.122, that's not enough. It just puts that as 122 on 1000, which is 61 on 500. So I fill the screen with the repeating decimal, and that tells me that's exactly 11 on 90. So that's actually, oh sorry, no, it's 11 on 90 here, isn't it? And I've got negative 4.333, that's looking to me like 4 1/3, which should be 13 on 3. And I get negative 13 on 3. Whoops. That's divided by, what was it, 90? And it was to the power of 2. And this becomes negative 13 on 3. And that's 50. And that's it.